reaction, that is the reduction potential of Mg2 plus 2Mg. Again, we know that we have to use SHE, standard hydrogen electrode, to find the reduction or electrode potential for any Redox couple. So here we'll do the same thing. We'll keep this as anode as per convention, and will this be a cathode? Right? We'll take 1 molar solution. This is SHE, which E as 0, and this we have to find. So this reaction I can write as what? Platinum, my hydrogen gas is oxidized to H plus, and here my Mg2 plus will become Mg. Correct? And why this is cathode? Because you need to find the electrode potential, that is nothing but reduction potential. So since here reduction will happen, so what you get is the exact value. So now here in this case E cell will be what? E right minus E left. That is nothing but E right is this guy. This is Mg, and this is Mg plus solution here. So this is E of Mg2 plus 2Mg minus E of left is, that is hydrogen, right? Hydrogen to, sorry, H plus 2H. Both reduction potential, and this is experimental value we get. And this is nothing but E of Mg2 plus 2Mg minus 0, and this is E cell experimental value. Because when you collect with voltmeter here, you will get this value here. So this is what you get, this, and this is what you have to find, and that is my answer. Correct? Because this value you will get experimentally. When the moment you set up this in your lab, you will get some value here. In the reading, whatever you get, just put the value, and that becomes your standard electrode potential of Mg2 plus 2Mg. The question is, can you store copper sulfate in zinc pot? So let's see this first. So I have copper sulfate, Cu2 plus, and I have a zinc pot. Zinc pot, the color is something like this. Now let's see the reduction potential. I have zinc is here, copper is here. Copper sulfate is Cu2 plus, right? So Cu2 plus to copper is 0.34 volt, and Zn2 plus to zinc is minus 0.76. That means this reaction is more feasible, right? More feasible. This is not feasible. But if you flip this reaction now, this reaction, Zn2 plus will give maybe 0.76 volt. That means now if you compare reaction 1, 2 and 3, if you compare reaction 1 and 2, obviously 1 is feasible, right? Because it's a negative value now. But if you compare 1 and 3, 3 is more feasible. Correct? So if you see neck to neck comparison, if you compare 1 and 2, okay, this reaction is feasible. But we are talking about a scenario where zinc, if you are putting in zinc, if zinc is getting oxidized, because I have these two things, right? I have copper sulfate solution and I have zinc. So I'll compare reaction 1 and 3. If you compare reaction 1 and 3, this is 0.76 volt, this is 0.3 volt. That means reaction 3 will rule. Reaction 3 will rule. That means zinc will become zinc sulfate. If zinc will become zinc sulfate, so copper will become, copper sulfate will become copper. So I have copper sulfate solution that will become copper, and zinc will get dissolved, right? So we cannot use zinc pot to store copper sulfate solution. But if the question is, can you store zinc sulfate in a copper pot? The answer will be yes. Why? Because then we have a zinc sulfate and we have a copper. So if you compare these reactions now, I have zinc sulfate and copper, then you will see that that is not feasible, because copper will not be able to displace zinc sulfate from its solution. Copper is weaker, but zinc can displace copper from its salt, but copper cannot displace zinc from its salt. Correct? The next question is, we have to consult the table of standard electrode potential and suggest 3 substances that can oxidize ferrous ions under suitable conditions. So something that can oxidize ferrous ions. First, let's mark this in red, right? The ferrous ions, this guy, ferric to ferrous, which can oxidize ferrous to ferric. That means something that can oxidize ferrous ions, that substance will be able to reduce faster than Fe3 plus to Fe2. Correct? See, something which can oxidize this from Fe2 to Fe3, that means they are the one which will be able to reduce faster than this. If they are able to reduce faster than this, then only they can actually oxidize them. Correct? So in that case, anything which has more reduction potential, because I'm talking about the ability to reduce, then this will be able to, for example, my fluorine, my chromium 3, MnO4 minus, Au3, or my bromine, or my chlorine, oxygen. These are my examples of substance that can oxidize ferrous ions. Why? You understood? See, Fe3 plus 2Fe2, the value is 0.77 volt. Right? Anything above this are the one which can easily get reduced then compared to this. If they can easily reduce themselves, that means they can oxidize.